My name's John Quick. I'm a principal scientist. I work for a company called ALS Environmental, and we're looking principally in our laboratory at the trace level organics analysis of pollutants in environmental water samples. I've worked within the industry for 30 years in various water companies and with the Environment Agency. I work in the Coventry laboratory, and we're looking principally at dirty water, environmental water analysis for trace level organic compounds, so pesticides, volatile compounds, pharmaceuticals, personal care products, that sort of thing. And we develop a range of methods looking for these compounds in environmental water samples down in the low parts per trillion down into the parts per quadrillion range. We've currently got about 30 GCMSs. The bulk of them are single quadrupole instruments, about half a dozen MSMS, and now we're looking to invest in time-of-flight technology. So we'll have 2 time-of-flight instruments as well. The real difference is a question of scale. Previously, the methods have involved taking a rather large amount of water sample, probably from 200 mils to a litre. What we're seeing now is that with the increasing sensitivity of the instrumentation, we can get away with taking a much smaller sample volume. So we're looking to standardise on 40 mils or below. And once you get down to that sort of level, it becomes feasible to automate. So miniaturisation is really the key to being able to automate, and we've devised a way of being able to automate the extraction of a wide range of organic compounds from just 9 mils a sample using a couple hundred microlitres of dichloromethane using a technique called dispersive liquid-liquid micro-extraction, which enables us to get about a 30-fold concentration factor. And to do this in an automated fashion. So there's minimal operator involvement, minimal operator exposure to solvents, and it's very efficient and quick as well. I think the attractive thing about time of flight is obviously we're looking at full range mass data all the time at a sensitivity which is similar to selected arm monitoring. So what we see is we see a big advantage in putting this together with our small scale extraction, so we can offer reporting limits at environmentally relevant concentrations. So we're down in the low nanogram per litre range for a large number of pollutants, and we can analyse simultaneously using time of flight for many hundreds at a single time. So we perceive that being very useful for customers who might want to profile water sources, for example. I'm sure it will. The drive to miniaturisation and automation means I think that we'll be looking to make large efficiency savings by introducing this methodology. The economics of the situation really drives it. It's a very highly competitive marketplace that we work in, and the advantages of this type of approach we believe are significant enough that we will see their adoption gradually within the marketplace over the course of the next few years. In the past, our customers will probably be looking at supplying us with litre bottles, 500 mils, maybe 250 ml bottles. We're looking to standardise on 40 ml vials, which will have big benefits on sampling, transport, storage. There'll be savings for both ourselves and our customers. And in a regulated type environment, that change will take time to come about because all the methods we introduce have to be validated and put forward for accreditation. So it won't happen overnight, but I believe that the savings that can be made in a very highly cost-driven environment will will make it fairly inevitable, I believe, that the analysis will move that way. And it's the result of two things. It's the increasing sensitivity of the instrumentation, time of flight now being available in the laboratory. That's happened at the same time as developments have been made on small-scale automation, robotics. So those two things have come along at the same time. And if you put those two things together, I believe the advantages are such that people will have to adopt this new technology in the future. We require fairly minimal training, to be honest. In some ways, it's easier to set an instrument up if you're looking at analysis on a quadrupole, for example, on selected arm monitoring or on MSMS. You're looking at setting your transitions or your selected iron groupings on the basis of retention time. So those need quite careful setup. Whereas a TOF, by contrast, where you're looking at full mass range data, it just acquires everything all the time. So it's actually a lot easier to set up, and you don't have those initial steps to go through. On MSMS, you've got to optimize the transitions. You've then got to write a method so that you're looking for the right transitions at the right retention time in your chromatogram. If it's selected on monitoring, you've got to make sure you're monitoring the right ions at the right time. There's none of that with the time of flight, because everything's in full range match data, all the time. So it's actually fairly simple to do.